All right, let's jump right in. We're going to cut through all the AI buzzwords today and get really clear on one big question. What is the actual difference between a neural network and a large language model? Let's figure it out. So you hear these terms thrown around all the time, right? AI, neural networks, LLMs, it can all start to sound like a big bowl of alphabet soup. Are they all basically the same thing? Or are they, different parts of a bigger system? Well, that's exactly what we're going to clear up right now. To really get a handle on this, we've got to start at the very bottom, with the absolute foundation of pretty much all modern AI. We're talking about neural networks. Okay, so think of a neural network as kind of like the single Lego brick of AI. The whole idea was actually inspired by our own brains. Its main job, its whole purpose is to look at a bunch of data, learn from examples, and just get incredibly good at spotting patterns. So how does it, work? Well, the structure is actually pretty straightforward. First up, you've got the input layer. That's where the data comes in. Could be anything, really. Pixels from a photo, numbers, whatever. Then, that data flows through these things called hidden layers. And this is where the real magic happens. This is where it finds the patterns. And finally, you get an output layer, which just gives you the final answer. And this is a perfect example. Let's say you show a neural network thousands and thousands of pictures of cats. Its hidden layers start to learn what a cat looks like, the pointy ears, the whiskers, the fur. Pretty soon, you can show it a totally new photo it's never seen before, and that output layer will go, yep, that's a cat. It's all about that pattern recognition. Okay, so that's our basic building block. But what happens when you take that simple idea and you don't just make it bigger? You make it unimaginably, colossally huge. Well, that's when you get a large language model. Now, this is maybe the most important part. An LLM isn't some totally new thing. It is a neural network. It's just a very, very special, supersized version that's been built for one specific, gigantic task: to understand and create human language. And you've for sure heard of these guys. Anytime you talk to something like ChatGPT or Gemini or Claude, you're talking to a large language model. These are the household names right now, and every single one of them is built on that same neural network idea we just covered. So what's their secret? After being fed a mind-boggling amount of text from the internet, an LLM's main skill sounds almost too simple. It just predicts the most likely next word in a sentence. That's it. But it turns out, when you get insanely good at just that one thing, you unlock all these other incredible abilities. Okay, so we've got our two main players. Now let's put them side by side so the differences really stand out. This is where it all starts to make sense. Okay, this table lays it out perfectly. A standard neural network, its purpose is to recognize patterns. Its output is just a simple label, like cat or a number. An LLM, though, is built to understand and generate language, and its output is actual human-like text. And just look at the size difference. We're talking small to medium versus astronomically large. Billions of parameters. It's a whole different universe. So if there's one thing you remember from all of this, make it this sentence. It's simple, but it's crucial. All LLMs are neural networks, but not all neural networks are LLMs. It's just like how all squares are rectangles, but not all rectangles are squares. It's the exact same relationship. I love this analogy because it makes it so clear. A regular neural network is like a single musician. They can get really, really good at playing one specific song. But an LLM, that's the full orchestra. It takes all of those individual parts and combines them to create something with harmony, complexity, and real meaning. So yeah, this orchestra is unbelievably powerful. But with that kind of power, you also get some pretty serious problems and limitations that we really, really need to know about. I mean, what they can do is just wild. It's so much more than spotting patterns. These things can write entire essays, summarize complicated articles, have a totally natural-sounding conversation, and even write computer code or translate languages. This is that orchestra playing at full blast. But, and this is a huge but, we have to remember they don't truly understand anything like a person does. They're just predicting the next word. And that can lead to something called hallucinations, which is a fancy way of saying they just make stuff up sometimes and say it with total confidence. Plus, they have limits to their memory, and they cost a fortune to train and run. They're powerful, for sure, but they are not perfect. So, let's wrap this all up. What's the big leap here? What does this jump from a simple pattern matcher to a complex communicator really mean for AI? I think it all comes down to this one idea. Neural networks gave AI the power to learn, but large language models gave AI the power to communicate. And that shift, from just learning to actually communicating, is one of the biggest changes in technology we've ever seen. Thanks for tuning in.